Hello, upper school. Today we're going to be walking through a couple different simulations that will help us take a look at climate change at the micro, the really tiny level, like molecule level, and the macroscopic level, like really big, like big rocks, mountains, glaciers, and stuff like that. Our objectives for today are to discover some causes and effects of increasing global temperature, determine the environmental factors that affect the motion and size of glaciers. That's our macroscopic level. That's this word here. And explain how greenhouse gases influence the temperature of the Earth. And that's more of a micro level problem. If you're wondering, how do I submit this? How do I let you know that I got it done, Mr. Grawl? There's two ways. The first way is if you've been by the school and you picked up a packet, you have this worksheet in your packet. You can just fill this out while we go along here. I'm going to be typing in my answers. I may not put an answer down. You still need to write something. I just want to see your thoughts. I don't kind of want you to copy down my thoughts, but for the most part, you'll be able to just to follow along with me. There's also a way that you can do it digitally. So if you're working on a laptop or a tablet, I don't recommend you trying to do this on a phone. If you are watching this video on the phone, you should just be doing the paper copy. But if you want, you can, in the Google Classroom assignment, there's a digital copy of this where you can click on it, get your own copy in a Google document, and just type your answers in and submit it on Google Classroom. So again, two ways you can submit it, either by paper or the Google Classroom document. Either one works for me. You'll get full credit either way. So it says open up the Fett Glacier simulation. So I have done that. If you have a laptop and you want to visit these and play around with them, you're more than welcome to. The link is right here, but I'm just going to walk you through it right here. So here we go. I'm going to kind of do this split screen if I can. 1, 2, there we go. Okay, it says, observe what happens to the glacier as you adjust the different parameters in the simulation. Record your observations in the table. So decrease the annual snowfall. So if I decrease the annual snowfall, what happens to the glacier? Well, the glacier retreats. So right here, I'm going to fill this in. Okay, it retreats. What about the maximum thickness? Well, how do I see that? I gotta go like this. That's where it was before. Okay, it's like 200 feet high. Glaciers are pretty big. Okay, this is with a lot of snowfall. If I decrease it, you guessed it, that maximum thickness goes down. Okay, actually 0 there. So it decreases. Okay. All right, it's another action we can do. I'm just looking at the simulation here. Let's raise the sea level air temperature. You should be writing that down when I just typed. So if I raise the temperature, can I reset this? Let me reset. Yes, reset all settings. Okay, if I increase the temperature, okay, same thing. It retreats and the maximum thickness decreases. Okay, see that? All right, what about, let's see, what about if we increase? Okay, if I increase the snowfall, click reset. Yep. Increase it. Look, it advances. And the maximum thickness here obviously increases. All right, and if we decrease the temperature, let me reset. Yes. If I decrease the temperature, what happens? It advances and the thickness, increases. You start to make some connections here about what's actually happening in our world. Are we increasing or decreasing the temperature? We're increasing it. And is that leading to more or less snowfall? It depends. That's a little bit more unpredictable. So what claims can we make about the relationship between the amount of snowfall and movement and thickness of the glacier? So we're looking at these two rows. If I increase the snowfall, what happens? If I decrease the snowfall, what happens? I'm going to be looking for your answer right here. I'm not going to write that answer down. What claims can you make about the average temperature? What happens when I raise it and decrease it? Okay, look over here. Okay, so again, I'm looking for your answer there. So take some time to write that down. You can pause me if you need to. It's one advantage of online learning is you can pause me to get me to stop talking. All right, so that is the glacier. That's just a real quick one. Next, we are going to go to a different simulation. Greenhouse gases. This one's pretty cool. All right, so what it says here is open up the PhET greenhouse simulation. Okay, what do you think these little molecules are? Well, the red ones are infrared photons. These are just heat and light. And the yellow ones are sunlight photons. It says adjust the concentration of greenhouse gases in the atmosphere and observe what happens. Record your observations in the table below. So I'm going to be playing around with the different amounts of greenhouse gases. Okay, that's right here. Lots of greenhouse gases, not so much. Okay, so we are in today. Okay, and then these are different. These are different time periods. So today, if I increase the amount, say lots of greenhouse gases, what happens to the sunlight? Okay, let's reset this. Let's let it play out. Okay, if I increase, what happens to the sunlight? Stays about the same. I'm sorry about that. So today, here's the greenhouse gas concentration. Okay. Sunlight, here's the atmosphere. Absorbed. So what I'm showing you here is once you see the sunlight comes down here, once it hits the earth, it's just absorbed. Okay, that's the sunlight, the yellow ones. What about the infrared photons? Are they doing the same thing? No, they're going down onto the earth and they're actually bouncing off of Earth's surface. The temperature. What are you noticing about the temperature? Okay. I'm going to say temperature is right. Okay, let's keep that in mind. All right, let's go to the Ice Age. All right, now what happens? Well, the sunlight's also, sunlight is now bouncing off. Yep, the infrared photons are doing the same thing. I'm just going to copy and paste that. And what about the temperature? The temperature is much lower. Think about why you might think that is. So what's the difference between these two? Okay, now no greenhouse gases. No greenhouse gases. So sunlight, oops. Sunlight is being absorbed when these yellow ones hit the earth here, they're just being absorbed. Infrared, interesting thing here is the infrared is coming into the atmosphere, bouncing off land, and then just floating off into space. And these ones I think I'll add photons bounce. They're not doing that here, unfortunately, which is bad. And why is it bad? Take a look at the temperature here. Okay, the temperature is -1, not a livable temperature. This would cause an ice age. Okay. Explore how different molecules, let me reset this. Photo absorption tab. So these are the same little things if I run this. Okay. So that's sunlight, and this is methane. Okay, sunlight passes right through methane. Infrared bounces off every once in a while. Okay. Let's try CO2. Bounces off. Infrared bounces off. H2O. Infrared is deflected. See these kind of going off? Nitrogen passes right through. No bouncing. Oxygen. Passes right through. No bounce. Okay. Let's try sunlight. Methane gas passes right through. Carbon dioxide passes right through. H2O passes right through. Nitrogen passes right through. Oxygen passes right through. All right, so let's try to find a pattern here. So right off the bat, the easy pattern is sunlight passes straight all gases. Why is it doing that? I do not want it to space out. However, infrared light bounces off of methane, carbon dioxide, and water. It passes straight through nitrogen and oxygen. So maybe the pattern is, for now, if the molecule has hydrogen, infrared will bounce. How did I figure that out? Well, this one has carbon and hydrogen. This one has carbon. This one just has hydrogen. And the one that just had oxygen, it passes right through. So I'm guessing that it has something to do with these hydrogens or these carbons. So which gases are considered greenhouse gases? The ones that act like a greenhouse. A greenhouse is a big glass house that we put plants in because it holds heat and sunlight in, infrared photons. So anything that bounces infrared photons is a greenhouse gas. That would be methane, which is carbon dioxide, the one you hear about a lot, CO2. And believe it or not, water vapor, H2O. Okay, so we're going to build an atmosphere with different, different greenhouse gases here. Lots of greenhouse gases. So let's just crank this one all the way up. Crank this one all the way up. Crank this one all the way up. Let's run that. what's happening to the infrared photons? The infrared photons bouncing all over. And visible photons, they are passing straight through. No greenhouse gases. None of them. 0, 0, 0. We'll put these ones all the way up. So nitrogen, oxygen. The visible photons passing straight through. The infrared. I'll make a prediction. The infrared photons, what are they doing? They are passing straight through. So what we want to do is we kind of want to, in real life, we want to balance this out. Okay, we want a nice balance between greenhouse gases, non-greenhouse gases, because if we have too many greenhouse gases, which we do right now, the heat will get trapped and it'll be too hot. We want a nice little balance between the infrared photons bouncing off of Earth, bouncing back, and just kind of keeping this nice warm blanket. This is kind of like the ideal. In 1750, before the Industrial Revolution, this was kind of like where we were doing all right. Okay, but today you see the temperatures going up over here. Our Earth is heating up because we have too many greenhouse gases. Okay, so let's talk about this. So number 1 and number 4. Use this data to explain how greenhouse gases can affect global temperature. Use microscopic evidence to explain the difference between the global temperature during the Ice Age and present day. So, microscopic evidence would be these photons, okay? So the temperature is around 59 degrees today. It was much lower in the Ice Age. Why? Well, here's the sentence starter. Greenhouse global temperature. Why? What do you think? Give you time to think about it. Increasing the amount of infrared. Might have a lot to do with it. Not really with temperature, no. But the infrared photons provide heat. So there were more infrared photons trapped in the atmosphere today than in, because there were less green. On top of that, there was also the world was covered in ice, which reflected a lot of that back into the atmosphere. Use your observations on the microscopic level to explain the macroscopic observations. So why do you think what we learned about infrared photons in this simulation, the greenhouse effect, can explain why our sea level temperatures are rising like that, and our average snowfall is decreasing like that. See how it's starting to recede? This is what's happening in real life. So why does the infrared photons today being trapped in our atmosphere lead to glaciers melting, receding, and becoming thinner? Let's go ahead and answer that question, and then we are done for the day. Thanks.